In the vast expanse of the universe, two frontiers are colliding: the mysteries of space and the limitless potential of artificial intelligence. For millennia, we have looked to the heavens, our curiosity boundless, our reach limited. But now, a new age of discovery is dawning, powered not just by human ingenuity, but by the remarkable capabilities of thinking machines. This is a story of how our own creations are helping us to understand creation itself, unlocking secrets held in the cosmic dark for eons. It is a tale of partnership, a new kind of explorer emerging from the digital ether to guide our journey into the unknown. The scale of the cosmos is almost beyond our comprehension. Billions of galaxies, each with billions of stars, a tapestry of immense complexity. This is where artificial intelligence enters the narrative. It can perceive patterns in the chaos, sift through mountains of data in mere moments. Join me as we embark on this extraordinary journey. We will venture from the heart of dying stars to the edge of our solar system. We are about to uncover 10 profound secrets revealed by this grand collaboration between human and machine. The age of AI-driven exploration has begun. For centuries, the question of whether we are alone in the universe has been a matter of philosophy and faith. But now, it is a question of science, answered one planet at a time. Telescopes like Kepler and TESS stare into the void, capturing the light of hundreds of thousands of stars, waiting for the telltale dimming. The sheer volume of this data is overwhelming, a torrent of light curves that would take human astronomers a lifetime to analyze. Here, in this deluge of cosmic information, our silent partner, artificial intelligence, begins its work. They are not bound by fatigue or preconception. They look for the faintest dips in starlight, patterns so subtle they might be dismissed as mere stellar noise or instrumental error. It is a process of digital archaeology, digging through layers of light to unearth new worlds. The AI doesn't just find candidates, it learns, and the results are truly breathtaking. Thanks to these AI-powered techniques, the number of known exoplanets has swelled into the thousands. We have found gas giants larger than Jupiter, rocky super-Earths, even planets orbiting two suns. AI is not just counting worlds, it is expanding the very map of what is possible in our galaxy. The International Space Station is a marvel of human engineering, an outpost of humanity suspended in the blackness of space. Life aboard this orbiting laboratory is demanding, a delicate ballet of scientific experiments, maintenance, and survival. To assist them, a new kind of crewmate has arrived, one that doesn't breathe air or need sleep. Its name is Simone, the Crew Interactive Mobile Companion. Simone is a free-floating spherical robot with an AI brain given a body to navigate zero gravity. It serves as a hands-free database and voice-activated assistant. This frees up the astronauts' hands and minds to focus on the intricate work before them. But its role extends beyond that of a simple tool. Simone is designed to be a conversational partner, detecting emotional state through voice analysis and providing encouragement. It is an experiment in human-robot interaction in one of the most extreme environments imaginable, testing how an AI can become a trusted colleague. As we plan for longer missions to the Moon, Mars, and beyond, the psychological well-being of the crew will be paramount. It represents the first small step towards a future where humans and intelligent machines explore the cosmos, not as master and servant, but as true partners. The death of a massive star is the most violent event in the universe, a supernova. In a fraction of a second, a star collapses, then explodes with the light of a billion suns. These cataclysmic events forge the heavy elements, the iron in our blood, the calcium in our bones, and scatter them across the cosmos. However, observing a supernova in its entirety is impossible. The core collapse happens too quickly, shrouded deep within the star. For decades, scientists have used supercomputers to model this complex physics, but even the most powerful machines struggle with the chaotic explosion. The equations can take months to run, and still often fail to produce a successful explosion. This is where AI is revolutionizing astrophysics. Instead of solving impossible physics directly, AI models learn underlying patterns from simplified simulations and past supernova observations. These AI-powered simulations can run in minutes, not months, exploring thousands of scenarios to find which lead to successful explosions. The insights are remarkable. AI is helping pinpoint the crucial role of turbulence, neutrinos, and magnetic fields in triggering the blast. By simulating stellar deaths with unprecedented speed and accuracy, AI is decoding the cosmic forges that created the very substance of our world. Our corner of space is not always tranquil. The sun has a tempestuous side, unleashing powerful solar flares and coronal mass ejections. These space weather events can disable satellites, disrupt power grids, and pose radiation risks to astronauts outside Earth's magnetic field. Predicting these cosmic storms has always been a challenge. The sun's behavior is incredibly complex, governed by magnetic fields that twist unpredictably. Traditional methods often give only hours of warning. For future Mars missions where astronauts face months in open space, a reliable early warning system is essential. Enter the AI forecaster. Machine learning algorithms are being fed decades of solar observation data from space-based observatories. They learn to recognize subtle precursors, faint changes in magnetic fields, plasma flows, ultraviolet emissions invisible to the human eye. The AI excels at pattern recognition on a scale we cannot match, predicting the likelihood, location, and intensity of solar flares days in advance. This is a paradigm shift in space weather forecasting, providing time to protect satellites, infrastructure, and allow astronauts to seek shelter. As we venture further from home, this AI-powered vigilance will be our shield against the unpredictable fury of our own star. For over 60 years, spacecraft design has been an iterative process of drawing boards, wind tunnels, and painstaking calculations. Engineers, brilliant as they are still guided by their experience, intuition, and the designs that have come before. But as we set our sights on more ambitious destinations, we need spacecraft that are lighter, stronger, and more efficient. This is a challenge perfectly suited for a different kind of mind, a generative AI that can explore vast, multi-dimensional design spaces. Engineers provide an AI with goals and constraints, the mission's destination, payload capacity, materials available, and forces the craft must withstand. The AI explores beyond conventional thinking, generating thousands of potential structures and testing each in virtual environments. Weak designs are discarded, strong ones are bred together, combining their best features through evolutionary processes. This results in forms that are organic, alien, strangely beautiful. They look less like they were built and more like they were grown. We're already seeing this technology used for satellite brackets, engine components, and lander legs, up to 40% lighter, yet stronger. AI is not just helping us explore the universe, it is designing the very vessels that will take us there. Since the dawn of the radio age, we have been listening. With giant radio telescopes, we scan the heavens, tuning into the natural symphony of the cosmos, the hiss of distant galaxies, the rhythmic pulse of neutron stars, and amidst this celestial noise, we search for something else. A signal that is not natural, a signal that is structured, complex, and artificial, a sign that someone else is broadcasting into the void. The search for extraterrestrial intelligence generates astronomical amounts of data, capturing wide radio spectrum from countless directions, 24 hours a day. Buried within this static could be a single, faint signal of intelligent origin. For humans, finding this needle in a cosmic haystack is near impossible. This is where AI has become SETI's most powerful new instrument, capable of processing volumes of random noise that overwhelm human brains. Algorithms can be trained to recognize natural radio signals, pulsars, quasars, and our own earthly interference from satellites and phones. Once trained, the AI can flag anything that doesn't fit the natural profile, a tireless, unbiased listener spotting anomalies we would miss. Recently, this technique has yielded intriguing results. AI has identified dozens of previously unnoticed signals from distant star systems. While none are yet confirmed as extraterrestrial, they represent our best hope for detecting that faint whisper from across the interstellar darkness. When we look at an image of a galaxy, we see a flat two-dimensional picture. But the universe exists in three glorious dimensions. Understanding the true structure of the cosmos, how galaxies are clustered into filaments, walls, and voids, is fundamental to cosmology. Creating a comprehensive three-dimensional map requires precise distance measurements to millions of galaxies, an incredibly data-intensive process. Telescopes like the Sloan Digital Sky Survey and Dark Energy Survey capture images of huge patches of the sky. To build a 3D map, astronomers must analyze light from each galaxy to determine its redshift, which tells us the galaxy's distance. Doing this for millions of galaxies one by one is a slow and laborious process that could take decades. AI is dramatically accelerating this cosmic cartography by learning subtle relationships between a galaxy's appearance and its distance. By analyzing color, shape, and brightness patterns, trained AI can estimate distances to millions of galaxies almost instantaneously. The result is the largest and most detailed three-dimensional maps of the universe ever conceived. We can now fly through virtual representations of the cosmos. These maps aren't just beautiful, they're powerful scientific tools for studying dark energy and testing our theories of cosmic evolution. AI is giving us a new dimension of sight. Narrator: everything we can see, the stars, planets, galaxies, accounts for only 5% of the universe. The rest is a profound mystery. Narrator: about 27% is thought to be a strange, invisible substance called dark matter. We cannot see it or touch it. Narrator: yet we know it must be there because we can see its gravitational effects, the invisible scaffolding that holds galaxies together. Narrator: detecting dark matter directly has proven impossible, so scientists hunt for it indirectly, observing its gravitational influence on light. Narrator: one powerful technique is gravitational lensing. When light passes by massive objects, its path is bent by gravity, much like light through a lens. Narrator: if there's a large clump of invisible dark matter present, it will distort the background galaxy image in a specific way. Narrator: finding these subtle distortions in countless galaxy images is an immense challenge. The lensing effects are weak and can be mimicked by other phenomena. Narrator: this is where AI's pattern recognition capabilities are invaluable. Scientists train AI on millions of simulated images, teaching it to spot dark matter's signature. Narrator: the AI learns to spot the faint characteristic warping that signals invisible mass presence. Narrator: this AI-powered search scans millions of galaxies for dark matter's fingerprint. It's a cosmic ghost hunt on the grandest scale, providing new eyes to see the invisible. The journey to becoming an astronaut is one of the most rigorous training programs on Earth, with countless hours in underwater laboratories. While this simulates weightlessness, it's an imperfect analog. Water drag is constant, and it's impossible to replicate extreme temperatures and vacuum, and the breathtaking, sometimes disorienting views of actual space simply cannot be reproduced in a pool. Now a new training tool is emerging, a combination of virtual reality and artificial intelligence that creates far more realistic simulations. Astronauts can be transported to digital replicas of the International Space Station or the surface of Mars. They can see Earth hanging below, stars unobscured by atmosphere, and feel true presence in that alien environment. But it's the AI that brings this virtual world to life, acting as a dynamic mission director, introducing unexpected problems. Sudden equipment malfunctions, micrometeoroid warnings, complex system failures. The AI adapts scenarios based on astronaut actions. This creates training that's not repetitive drill, but genuine tests of problem-solving under pressure, preparing minds for unknown challenges. When they face real crises millions of miles from home, they'll have already seen and solved them in the virtual world. The story of modern space exploration is increasingly about two minds, the human and the artificial, working together in unprecedented partnership. From discovering new worlds to designing ships, from predicting cosmic storms to training explorers, AI is becoming indispensable. But we're witnessing not the replacement of human explorers, but the dawn of a powerful new symbiosis, a deep and integrated partnership. Imagine astronauts on Mars with AI-powered rovers autonomously navigating, identifying rock samples, performing preliminary analysis. The AI handles the mundane, repetitive, and dangerous, freeing human astronauts to observe, question, and make intuitive leaps of discovery. Think of AI as the ultimate mission specialist: geology, biology, engineering, held in memory and ready to advise. Monitoring crew health, analyzing orbiter data to warn of dust storms, identifying safe paths through treacherous terrain. AI as guardian, analyst, scout, allowing us to dream on grander scales than ever before. With AI as our ally, missions once seeming like science fiction become possible, exploring icy moons, permanent lunar presence, first human footsteps on Mars. These great adventures will be challenging and dangerous, but we won't face them alone. We'll go as a new kind of team, walking together into the vast, silent frontier. We stand at a remarkable crossroads in human history. The desire to explore is etched into our very DNA, a legacy that has taken us from the plains of Africa to the surface of the moon. Now that same spirit has led us to create a new intelligence, becoming our partner in the greatest exploration of all. The secrets we've uncovered today are just the beginning. First whispers from a cosmos slowly revealing its wonders through extraordinary collaboration. The universe is a book of infinite pages, and for the first time, we have a way to help us read it. From the smallest particles to the largest structures, AI is providing us with a new lens through which to see. It is augmenting our intellect, expanding our senses, accelerating our quest for knowledge at unprecedented rates. This is not a distant future, it's happening right now. Today's discoveries will pave the way for the next generation of explorers, who will venture further and see more than we can imagine with their AI companions by their side. The journey into the cosmic ocean is long, and we have only just left the shore. But we're no longer navigating by stars alone, we're charting our course with intelligence born from our own curiosity. As we reach for the stars, AI is becoming our greatest ally. The future of exploration is here. Are you ready to join the journey?